This is a video about climate change and its effects on the marine environment. A lot of the things that I'm going to talk about reflect back on the issues that arise due to temperature increases. And that's due to the greenhouse gas concentration in the atmosphere. So GHG stands for greenhouse gases. We're talking mainly about carbon dioxide from industrial activities and changing land use practices, as well as methane, also from changing land use activities and agriculture and things like that. So because of these heat-trapping gases increasing in concentration in our atmosphere, we have increasing global temperatures, which can then, the energy is absorbed by the ocean, so we have the increasing sea surface temperatures. So that underlies a lot of the things that I'll be talking about. I'm also going to explain a little bit about feedback loops because they're pretty important in the marine environment. And then we'll look at several different results of climate change due to either the increasing greenhouse gas composition or the temperature increases. So a little bit about these feedback loops. A feedback loop is the idea of feedback is that information that comes in or a response that comes in after an event has taken place either positively affects that, meaning continues it or amplifies it, makes it bigger, or the feedback from the environment causes the initial reaction to decrease or be corrected. We're familiar with positive feedback being good and being given positive feedback ourselves for good behaviors and things like that. However, there's no judgment in the environment when it comes to feedback loops. Positive means making more. And so we see this with respect to climatic feedback quite a bit. Unfortunately, most of the examples that we see in terms of the environment responding to climate change are positive or amplifying, meaning they make the climate change processes continue or get bigger. So a very easy to understand example is the issue of ice, Arctic ice. We have temperatures rising, which is pretty easy to understand that causes ice to melt. Ice is a pretty white, reflective surface, unlike the darker water around it. And so the sunlight that bounces off ice is now hitting darker water and being absorbed, which means that there is more water, more heat being absorbed, more energy being absorbed by the Earth as climate change happens, which causes more temperature rise, which causes more ice to melt, which means more sunlight is absorbed and heat is being trapped in our ecosystems. So let's talk a little bit about that in particular. Ice is incredibly important in a lot of ways, especially for marine systems. A lot of us are familiar with the idea of this being habitat for critters, such as seals that would need to come up onto the ice in order to give birth because it's nice and isolated from other potential predators. This issue of reflectivity of sunlight is referred to as albedo. So the reflective albedo of the ice is also incredibly important in climate, global climate. So albedo is simply a measure of how reflective a surface is. And we can see that the white, fresh snow and ice reflects most of the light that hits it, as opposed to water near the Earth's, where when most of the sunlight is hitting it, a lot of it is being absorbed. That sunlight is being absorbed, and therefore when energy like sunlight gets absorbed by water or by the surfaces around it, that absorbs the energy and gets translated into heat. Ice is also incredibly important in terms of the salinity of the environment around it because ice is composed almost entirely of fresh water. And so when we're talking about melting of ice in a marine environment, Large quantities of ice melting can actually change the salinity in the way that large quantities of ice forming changes the salinity. And so in ecosystems where large amounts of ice is melting, we're very concerned about the salinity changing and that therefore altering the habitat of those marine organisms. And also due to density issues, changing salinity can alter the way that the water moves. And there are some major oceanic currents that depend on salinity increases or decreases, causing the water to sink because it becomes denser or more buoyant. And so if that changes, we are concerned about some major current changes. Another problem associated with climate change in the oceans is acidification. Now, this doesn't have to do with the temperature side of things, but it does have to do with carbon dioxide. Carbon dioxide dissolves into the water from the air, so CO2 in the air can just dissolve straight into the water. And this happens naturally. It also comes out of solution. But the more carbon dioxide in the air, the greater the probability that carbon dioxide will dissolve into the water. Carbon dioxide in the water can interact with the H2O molecules themselves and also these carbonate ions that form. And the problem is that carbonate by itself, this ion, is incredibly important for anything that needs to build a shell. So calcium carbonate is the main component of coral shells, of seashells, any kind of shell. And when there is more carbon dioxide dissolving into the water, those carbonate ions combine with the water and the carbon dioxide to form bicarbonate, which is not used for making shell. And so we see some problems associated with this. And I'll make a separate video to talk about this in more depth. We also have the issue of sea level rise, and most people are familiar with this concern. What they may not realize is the #1 cause of sea level rise is something called thermal expansion. It's the issue of water molecules taking up more space as they wiggle around, as they absorb more energy. And so as sea surface temperatures rise, the H2O molecules have more energy, they have heat energy, and this is causing them to literally take up more space. So the volume of water at room temperature would increase if we doubled that. Now, obviously, we're not talking about doubling the volume. We're talking about raising the temperature of the oceans only a few degrees. But the oceans are composed of cubic kilometers, cubic miles of water. And as that material takes on enough energy to take up just a little tiny bit more space, just thermally expand a little bit, the overall effect is for the oceans to actually get quite a bit higher up the shoreline. And so thermal expansion, given the great volume of the oceans, is the #1 cause for sea level rise. The secondary cause for sea level rise is the issue of land ice melting. We specify land ice because if you think about the amount of ice sitting on top of Greenland or Antarctica, these ice sheets are not currently contributing to the volume of water in the ocean. Icebergs are already in the ocean, so their volume is already accounted for. But as this ice on land, in addition to the other glaciers that we have, as this starts to melt and add its liquid volume to the ocean's liquid volume, this is enough to make at least some contribution to the greater volume of water in the oceans. But thermal expansion, given how much water is already in there, is a much greater problem to cause the level of oceans to rise. And of course, we feel that in coastal ecosystems the most. So why do we worry about this? Well, first of all, we have to worry about food webs. This is important ecologically and it's important economically for a lot of the food that we catch in the marine world. Plankton, which are the basis of the food webs for pretty much any food web, they are very susceptible, whether we're talking about tiny phytoplankton that make shells that could be dissolved or could have a harder time making those shells due to ocean acidification, or zooplankton, the things that eat the phytoplankton, not being able to make their shells. This is a huge problem for organisms. If the basis of the food web is gone, then the rest of the organisms that rely on it, there's nothing for them, right? The other issue we have to think about is sea surface temperatures, making conditions very hard for various organisms, and they may be susceptible to disease and other problems that then cause their predators to die off. Finally, we mentioned the issue of habitat loss in terms of sea ice melting in the face of rising sea surface temperatures. As sea level rise, we worry about coastal ecosystems like mangroves and salt marshes and intertidal zones. Finally, we also worry about subsurface or subtidal ecosystems, whether these are seagrass beds or coral reefs. Higher temperatures stress out the organisms. Greater depth of water can reduce the amount of sunlight, and in connection with things like intensified storms, we can see more sediment getting into the water and causing a problem in those ecosystems that are near the coast but are below water. So let me skip to intensified storms. Warmer temperatures mean that more water evaporates, and between those two pieces, we get more water in the atmosphere, higher rates of winds, and so this is why we have seen an increase in not only the frequency of storms, the number of named hurricanes is getting bigger and bigger every year, and also the intensity. There's a lot of concern that with more water up in the atmosphere, the potential for flooding, for thunderstorms, this can only increase. When this is combined with some high tide events, we see some very serious problems in coastal ecosystems, whether you're talking about the human side of things or the ecological side of things. And we also know that as humans carry organisms around the world, we're changing ecosystems, and potentially some of the things that were not able to take hold before, some potential introduced invasive species. As conditions change, these new organisms could thrive where they couldn't before. So we are concerned about introduced invasive species being able to take over where they couldn't before due to climate change. Finally, there's this challenging issue of seasonality. So there are some organisms that pattern their behavior and their life cycle around seasons in terms of sunlight availability and lunar cycles. Other species may react to different amounts of temperature. So as the temperature warms, a tree is able to bloom, and the same is true in the marine environment. Certain phytoplankton flourish under more sunlight, and others need warmer temperatures. So if the food of one species relies on temperature or sunlight or lunar cycle cues, and the predator relies on temperature changes or vice versa, we're seeing that these two things no longer line up in the same way that they would be as temperature changes and as global temperatures rise. And so when we have those two things no longer being in the same pattern as they used to be, there are problems associated with that on an ecological level.